Force due to gravity, part 3. So we haven't talked about why we use the center of mass when we calculate force due to gravity. The real reason? Well, calculus. So in other terms, it's because we're adding up the force due to gravity from all the tiny little parts of an object. And the center of mass is where that all averages out. So if I concentrated all the mass that's in that object, and I put it all at that single point at the center of mass, the force would actually be the same. So how do we find the center of mass? Well, in AP Physics 1, we're just going to use symmetry, because we're only going to look at highly symmetric objects. So things like spheres, cylinders, rods. So you can remember from Unit 1 how we did this. You can always go back and review those lessons. But mostly when we're talking gravitational pull, we're going to use the center of a sphere, because very frequently we're talking about planets or the moon or something that's spherically shaped. Otherwise, we're just going to pick a point, or we'll just define the distance without necessarily calculating the center. So while we're on the subject of mass, this mass in the equation, is it still inertial mass? No, this is now what we call gravitational mass. But also yes, because inertial mass and gravitational mass are numerically identical. What? So why are inertial mass and gravitational mass equal? Okay, imagine you're standing in an elevator. So you have no idea what's surrounding the elevator. That one's broken. Anyway, on Earth, at rest, all you feel is an acceleration due to gravity. Okay. The force you feel depends on your gravitational mass. Now, pretend the elevator's somewhere in space, right? And now it's accelerating at 9.8 meters per second squared. The force you feel is actually the same as the force you would feel on Earth. But this one depends on your inertial mass, not your gravitational mass, because now the force is not coming from gravity. But because the forces you felt were the same, gravitational mass and inertial mass must have equal values. We'll get to that one more again in our next unit.